2021 paper 1 of mathematics. It consists 4 sections. In section 1 contains 4 questions, in which first question is from circle, second question from area under the curves, third question is from probability, fourth question is from complex number. Section 2 consists 3 comprehension. Each comprehension has 2 questions. First comprehension from probability, second comprehension from matrices, and third comprehension from straight lines. And section 3 consists from 6 questions. First question from matrices, second question from quadratic equation, including the concept of AOD, you can say. Question number 13, which is from probability. Question number 14 from matrices. Question number 15 from inverse trigonometric function, including concept of limits. Question number 16 consists from complex number. And section 4 consists 3 questions. First question from quadratic equation, next from SOT, solution of triangle, then last question that is from vector.
So let's start solving the paper of JEE 2021 Advanced right after this short break.
Section 1. As question is asking over here that you have to find the equation of circle passing through vertices of the triangle. Means triangle is described such that ortho center is 1, 1, and consider a triangle whose 2 sides lie on the x-axis and the line x plus y equal to 1. So here I will describe a couple of methods to solve this. First of all, let me draw x-axis, and which is here one of the sides lie on this x-axis, and another that what we call that is the side that what we say this is, say let another side is x plus y plus 1 equal to 0, you can say, okay, and let the third side be somehow like this one. So let 3 sides of the triangles are such that one of the side is, let's say this is y equal to 0, actually this is x-axis, and this, this line that we say, let's see, y plus 1 equal to 0, this line, okay, and go ahead for this one, so that make the perpendicular from the vertices. Let me draw the perpendicular from the vertices over here. This is the perpendicular, one of the perpendicular, another perpendicular is this one, let's say, okay. So, and this is the other perpendicular. So this is the point where we say this is the ortho center. Ortho center usually we assign with h, and this h is 1, 1 given the question. You see that this is 1, 1, okay, fine. Now you can see over here this line we can evaluate. This is x plus y plus 1 equal to 0. So here slope is minus 1, and so here the slope will be 1, and it is passing through this one, let's say x plus y, it will be x minus y. So slope is as it is perpendicular to minus 1. This is minus 1, so the slope is plus 1. So x plus y equal to, that is y equal to minus x, y equal to x, so x minus y equal to 0, right? As it is passing through 0. So here we get the perpendicular of this line to this perpendicular, as this is 90 degree. So the equation of a circle, if you say, let the equation of circle be x square plus y square plus 2gx plus 2fy. This is a general form of the circle. So minus 1 comma 0 satisfies, minus 1 comma 0 satisfies this equation, satisfies equation number 1, let's satisfies, and what we get here, that will be 1 minus 2g equal to 0, and this implies that g equal to, that we say that 1 by 2, okay, so we get g equal to 1 by 2, fine, okay. Now g, as you know, that is 1 by 2, g you got, that is 1 by 2, right? Now you have to find f and c also, no? So as you know, this is, can you find this point? Okay, So as you know, this is h minus 1 comma 1. Similarly, you can go ahead for this one also. This line is, you know, you can find this is y equal to 0. So this is parallel to y-axis, as you know. This line, as this is perpendicular to this x-axis, so this is 1. So 1 will satisfy it over here. So its x coordinate is 1. It's very clear. As the x coordinate is 1, so we put here 1 here. We get that is 2, y equal to minus 2. So here 1 and minus 2 will be the point. 1 comma minus 2. 1 comma minus 2, yes. So 1 comma minus 2 satisfies over here. Also to this equation as 1 comma minus 2. So 1 comma minus 2 satisfies. So this equation number 1. So what we say here? 4 plus 1, 5, right? Plus 2g, that is 2 and minus 4. So that is 1 minus 4f, right? Minus 2, 4f. And here is equal to 0. Okay. Now you see this implies f equal to, that is 3 by 2. Okay. So that is f equal to, you can say here 3 by 2. This is another. As f you got 3 by 2. Once you get g, f, you can find here c also. So the equation of circle, it is very clear that as it is passing through 0, 0 also. So the another point is 0, and here the coordinate is 0, 0. Okay. This is x-axis, which satisfies this equation. So 0, 0 satisfies, means c equal to 0. So equation of circumcircle is, here it is very clear, that is x square plus y square. Equation of circumcircle is x square plus y square plus x plus 3y equal to 0, which shows this is the option, correct? This the option is correct. Achha, one more method I can show over here. It's pretty easy. If you know that here that is image of orthocenter about any side of the triangle lies on circumcircle, as you know. That is. So if we apply this concept, then you will get the complete idea here. That is image of orthocenter. Say here orthocenter about any side, about any sides of triangle lies on circumcircle. Lies on circumcircle. Okay. So if you see as 1, 1 is the orthocenter, so image of 1, 1 about y equal to 0, about y equal to, this is a smart solution, you can say. Y equal to 0 is 1, minus 1. It's very clear. It's okay. So one of the side is given, that is the x-axis, and for the another, so the image of, and similarly that what we see here, so the image of not 1, 1, same point is, so the image of 1, 1, that is about the line, let's say another line is given in the question, x plus y plus 1 equal to 0. You can check over here. Two equations were given in the question, and we will use this equation. One of them is x-axis, and other is x plus y plus 1 equal to 0. So about this line, if you are finding the image, then you will get the image concept, you can say. Very easily you can find the image, that is minus 1, 0. Once you get these 2 points, those 2 points will lie on the circle. So let the equation of circle be same working. You have to go ahead, right, by satisfying this one, means 1, 1, that is minus 1 comma 0, and one more point, another line, when you will find this one, another line, that is one point is, that is minus 2 comma minus 2. Okay, so about the line, this one is not minus 1 comma 0. So the image of 1 comma 1 about the line x plus y plus 1 equal to 0 is 2 comma minus 2. 2 comma minus 2. Okay, check here. So the image of this line, so the image of 1 comma 1 about the point line x, about the line x plus y plus 1 equal to 0 is minus 2 comma minus 2. You can find over here. And you say intersection of y equal to 0 and intersection of y equal to 0 and x plus y plus 1 equal to 0 is, that is minus 1 comma 0, right? So let the equation of circle be x square plus y square plus 2gx plus 2fi plus c equal to 0. So if you satisfy this 3 points, 1 comma minus 1 minus 2 comma minus 2 minus 1 comma 0, then you get this value gfc as same. So g will be here, that is 1 by 2, and f will be here, that is 3 by 2, and c will be here 0. Nearly same working here to go ahead. And this implies equation of circle will be x square plus y square plus x plus 3y equal to 0. That is the equation. Okay. So this is a solution of first question. First of all, we will draw this curve. Okay. So let me draw this curve. Let's say this is x-axis. Let me draw y-axis over here. Let's say this will be 9 by 4 equal to 3y. All here will draw. First of all, draw the line x plus y equal to 2 means intersect is 2 comma 0 and 0 comma 2. So nearly the line is like this way. So 2 comma 0 will be this point because this is 9 by 4, so this will be 2 comma 0. And right, so that thing will be clear. So this is 2 comma 0. Okay. So this line is 2 comma 0 and this is x plus y plus equal to 2. This is x plus y equal to 2. And let's say this line is, the line is there, that is y equal to 1, we have to draw. We have to draw over the line, that is y equal to 1. So we have to draw line y equal to 1, but if you draw y equal to 1, then this will disturb because this line is here, that is x equal to 3y. So when you put 9 by 4, so 9 3 27 by 4, that is some of it later from 1. So this is 3 comma 1 here. It intersects like this one, like this. Okay, so better we just draw like this one. X equal to 3y. Okay, fine. So now the picture is clear somehow. Let's say this point will be 3 comma 1 because this line is here, that is x equal to 3y, and this is y equal to 0 as this is x-axis. And this point also you can find by solving 3 by 2 comma 1 by 2. Okay, 3 by 2 comma 1 by 2. And this point you can say point should be clear, 9 by 4 comma 3 by 4. Okay, so once you get the vertices 9 by 4 comma 0 in this question, then you are able to do this solve this question very easy manner, because here what now thing is clear somehow. If you see the equations and constraints of these equations, you check the constraints in this equation. Now x lies between 0 to 9 by 4. What it means? It means that here, that is x lies between 0 to 9 by 4. Means you have to go in this region and in this region, right? And then after, if you see that here somehow, look at point here, between these two regions, you have to go. So if you see x plus y is greater or equal to 2, so that it means in this region. you have to go in this region, in this region, in this region, beyond this line, right? For this one. And if you say x is greater than 3y, so that it means x is greater than 3y, x is greater. So we have to go like this, in this region of this line, in this region, right? In this region. So the common region will be here, if you see. And one thing is the y lies between 0 to 1. So here and here this region. So between this region you have to show this. So that it means this region you have to consider here. That it means this is a quadrilateral embedded with the vertices 2, 0, 9 by 4, 0, 9 by 4, 3 by 4 and 3 by 2, 1 by 2. Correct. Very easy. You can find the area of the quadrilateral. We have given the quicker method also. Or in any way you can join this two line and make it's like this way, two triangles, which is the combination of the two triangles you can say over here. Right? You can say this will be the combination of the two triangles, and by the help of this three vertices, using the area of triangle, you can find. So better just find the area of triangle by using determinant method. So some of the area of the triangle is, or directly you can use the formula of quadrilateral. So let's go ahead and solve. Delta is equal to half of. Let's see. So delta is equal to half of. Let me draw the determinant. Okay. So 3 order determinant you can use also, or 2 order also. So better just 3 by 2. Traditionally I am using this one, so everybody can get the idea. 3 by 2, 0, 1, 9 by 4, 3 by 4, and here you can say that is 1, right? And plus that is half of another triangle, that is, it's very clear. That is 9 by 2, half of, that is 9 by 4 minus 2 into, that is 3 by 4. Let's say, okay. So solving this all, you will get this one 11 by 32. Okay. But if you read the question carefully and find the situation, then the concept is pretty easy. Although the basic fundamental concept of probability is very easy over here, number of favorable situation to that of number of sample space, which is the definition of the probability, classical definition of the probability. But you have to read this question very carefully. Just there is a test of only the reading analogy of the students, nothing else. Now let's see, without wasting time. Consider three sets E1, 1, 2, 3, F1, 1, 2, 3, 4, G1, 2, 3, 4, 5. Two elements are chosen at random, right? Without replacement. You have to be notified at that point, without replacement from the set E1, and let set S1 denote the set of those chosen elements, so that E2 equal to E1 minus S1. These conditions are given. F2 is equal to F1 union S1. These conditions you can go ahead. So here this is an example how to just we can go for E1 and E2. So if you think about what the E1 is, let's say E1. So E1 is in the E1's event. E1 is the set of 1, 2, 3, 3 elements. There are 1, 2, 3. So let me draw here. That is, let's say this is E1. Okay. Let me draw E1. Okay. So let's say this is E1 is here. You can say, and then come again 1, 2, 3. Okay. Now look at the point here. So here that is. If you go through tree methods, so we will use their tree method. So 3 different situations will be there. In one of the situation, let me draw one by one every situation. So if we see in first situation, then what we will recall here, that S1 will be, you have to consider S1, so that here the condition is given in the question, that here you have to see this one as like S1 here 1, 2 they have chosen, so that given that E1 equal to E3, so you have to always consider this situation like this one. So let's say this is S1. Let's assume S1 as 1, 2, right? So if I consider 2 elements 1, 2, so E2 will be what? E2 will be there. How to find E2? you can see over here. E2 you can find by this one, E1 minus S1. So 1, 2, 3 E1 and S1 is 1, 2. So in E2, what the element will be there? So in E2 you can see here the only in E1 1, 2, 3 and 1, 2 you have to means eliminate. So only 3 will be left. So in E2 set there is only 3 element will be there, right? What about this one F2? Similarly, F2 is also for the F2 condition is also given here. What is F2? Let's see over here. F2 is F1 union S1. And what is F1? That is 1, 3, 4. Okay, 1, 3, 4 and this S1 is 1, 2. When you make the union of this 1, 3, 4 and 1, 2, then what you will find? The elements are 1, 2, 3, 4, right? So in F4, there are 1, 2, 3, 4 elements. So here, what the situation will be there? So you can see how this S2 be chosen. So S2 can be chosen like this way, as like, look here. Okay, let me do. So in this situation, what we will recall that when you choose S2 like this, when you choose S2 as 1, 2, right? S2 can be chosen as 1, 2, or you can choose as you can choose this S2 similarly 1, 3, right? And here 1, 4. That is the sample space. 1, 4. Okay. As like 1, 2, 1, 3, 1, 4. You have to go ahead. And for this, G2 will be there. G2 will be there. That is 1, 2, 3, 4, and 5. Just clear? And if you see, that is 2, 3. We consider 2, 3. Then 2, 4. And then we say 3, 4. Right? So in this situation, what we consider here, that is 2, 3, 4, 5. 2, 3, 4, 5. Okay. And in this situation, so from here, E3 will be there. That is 1, 2, 3, 4. So here there are the two different situations. This is G2. G2 will be either 1, 2, 3, 4, 5 or 2, 3, 4, 5. So if we choose G2 from here, let's say this one. So let's say in this two situation, what we say 1, 2. Let me take here. This is 1, 2. The curly bracket. 1, 2 and the curly bracket. Okay. So for this 1, 2, 3, 4, 5, 1, 2 we have to choose, and for this 2, 3, 4, 5, 1, 2, 0 we have to choose. So in this situation, E3 will become, let me check whether it is E3, we have to consider all those situations when here that is E3 becomes E1. We have that E3 equal to E1. So what is E1 over here? Here that is E1 we have chosen, that is 1, 2, 3. So whether you got E3 as 1, 2, 3, 4, 5, let's see. So E3 we are getting 1, 2, 3. 1, 2, and 3. So that is same E1. Okay. So this is the situation over here. Let me recall this. This is one of the cases of E1 that we are chosen over here. Check this. So this is the case over here. Okay. So we'll select this E1. Similarly, if we go another situation, that is E2, like this. Right. In another situation, what we see here, we select this. Similarly, you can go ahead for E3. Let's see. When E1 is this one, let's say. So in this situation, what we see that S1 is here. We have chosen 1, 2. So S1, what we call that is 2, 3, right? And S1 will become 2, 3. S1 will become here 2, 3. So when S1 becomes as 2, 3, right? So E2 will become E2, that is 1. E2 is under curly bracket 1, and F2 that is 1, 2, 3, 4. F2 that is 1, 2, 3, and 4. Okay. So from here, if you see, that is how this becomes as like in this situation. If you see over here, that is means from 1, 2, 3, 4, we have to choose as S2. That is from 1 we can select 1 like this one. Select this manner. So that is say 1, right? And this is as 1, 3, right? And then after when we go for 2, so that is all here. 1, 4 is also there. 1, 4 will be also there. Okay. 1, 4 will be also there from 1. And when we go for 2, so 2, 3 will be there. So when we are 2, that is 2, 3, 2, 4 we have already selected. No, 2, 4 will be also there. Yes. And then 3, 4 will be there. Then here 3, 4 will be there. So these possibilities here. So 3, 3, 6, 4 C2, 6. From among 4, you have to make a 2 for combination. Here also, you have to make this 6 combination you will get here, just like here from F2. So that we say here. So if you say this as 1, 2, right, or this one S2, or this as S2, and that is 1, 2, that is 1, 3, okay, and 1, 4, yeah. Then after 2, 3, and then after means early bracket also 2, 3, then after 2, 4, and then after that is 3, 4. So what we recall here, that is 3, 4, right? That is 3, 4. Okay. Now this is the part here. Let's see from here, that is 1, 1, 2. Similarly here also 1, 3, right? Similarly here also 1, 4. For 2, that is 2, 3. For here that is 2, 4. Here that is 3, 4. Okay, fine. So as usual here, what we get here, just like if you see in this situation, that is in this situation 1, 2, 3, 4, 5, and this is for G2, that is 2, 3, 4, 5. So here that is if you say for G1, that is G2 means that is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and here that is called 2, 3, 4, 5, 2, 3, 4, 5, the two distribution. So among this, what the common function will be there. So if you see over here, then here we take this situation, that is 2, 3, and for this very, that is 2, 3, right? So that's the common quotient. So for this, you get E2 equal to, once again, 1, 2, 3. E2 that is equal to, that is called 1, 2, 3. E2 what we, E3 will be 1, 2, 3, right? Like this. You can see here also, and here also. So here also you can go ahead like this one. Also and here also. See, like this one. So for this 2, 3, you get this 1, 2, 3. Clear? So in this way, E3 equal to E1. Similarly, if you discuss about this whole situation for S means S1, that is as we have chosen 1, 2 here, and here that is 2, 3, and if we make the tree flow diagram, tree diagram here for 1, 3, then we will get the same situation here. Let me make this diagram to show you understanding of this all. Short of this get some more space. This E3, that we belong to C3, and then one more situation will be here, that is what is okay, fine. So situation here. Okay. So in this situation, that is S1, what we will recall. Let's work. So for this, let me draw this one more tree diagram. That is S1, that is 1, 3, right? And here E2, that is 2, okay? And then after what we see over here, that is F2, that is 1, 3, 4, okay? And then after what we will recall over here, that is like this. So for this very, that is F2, 1, 3. This one provides the most questions over here. So here what we recall, that is okay. So if you see this one like this, that is 1, 3. Okay. Here 1, 4. So here what we will go for 3, 4, right? And with this, if we carry out, and that is 1, 2, 3, 4, 5, and under this situation, that is that what we call 2, 3, 4, 5. Okay, fine. So if you carry out over here, then what we will see here, that is 1, 2, 3, 4, 5, and here also that is 1, 2, 3, 4, 5. So finally E3 we get 1, 2, 3. So in this situation, what we see, so probability you have to find when E1 equal to E3. This is our only case here. Okay. So we have to finally evaluate that probability of E1 E2 E3. Let's see over here. So let me share this out. So, in this situation, we got this. Okay, fine. So let's find the probability of E1 equal to E3. Okay. So what do we say here? Probability E1 equal to E3. Okay, fine. So this here, what we see is probability of E1 equal to E3, right? And here that is 1 by 3 of that what we call 1 by 2 into 1 by 10 plus 1 by 2 into 0, right? And plus 1 by 2 into 1 by 10 plus 1 by 2 into, that is called 1 by 6, 1 by 6 plus, that is 2 by 3 into 1 by 10 and plus 1 by 3 to 0. So this is right now. if you solve, then what we will get here? 1 by 3, and solving this all, you will find that is 1 by 4. And hence, answer will be, this is the sample space. And so the favorable case, that is called 1 by 3 types of, that is 1 by 2 into 1 by 10, right? So this will be the favorable case. Then here, second one. So let me find this one, 1 by 2 into 0 plus 1 by 2 into 10. So what we see over here, that is 1 by 3. So required probability, required probability that we say here. What is the case of required probability? Required probability is equal to 1 by 3 into, that is 1 by 2 into 1 by 10, right? And divided by, that is 1 by 3 into 1 by 4. That is the sample space. What we find, that is 1 by 5, and that's our answer. So final answer is 1 by 5. Let's see over here. 1 by 5 is first option is correct. E option. Similarly, you can go for fourth question. And fourth question, that is the from complex number. We will discuss detail. This is a good question of complex number. So you see, this is the question from complex number. This question is from complex number. Let's see over here. Let me take in the board. And this is question. What is the application of? So let me take the question. Zk is equal to this given theta 1 plus theta 2 2 pi. Okay. So Z1, Z2, Z3 are the up to, there are 10 complex numbers. All lie on the circle of radius 1. Let's say circle of radius unit. So first we draw the circle. Let me draw the circle here. Let's say this be the circle. Means this is x-axis, y-axis actually. You see over here. Let me draw the circle. So let me draw the circle. Yeah. So let's draw the circle. Let's say this be the circle. Okay. So if we see that let Z1 making an angle theta over here, let that Z1 be, Z1 means from origin, that is called, that is Z1. So let me draw this one line, white line. Okay. Let me put from origin over here, and then we put anywhere on the periphery of the circle. So let's say this is Z1, and another line that is called Z2. And this is here Z2. Z2 be the another complex number from origin. So if we see this circle, let's say this be x and this y-axis. From x-axis, the Z1 is making theta 1 angle, right? So let's say this angle is theta 1. This will be theta 1. Okay. This angle is here, theta 1. And what about this angle? So from here, this angle is theta 2. And let's say this is Z1, and here that is Z2. Okay. So if we join these 2 points over here, then what we will think about? What we think about Z2 minus Z1, this distance. So now you see that Z2 minus Z1, now you can see over here, that is Z2 minus Z1, this line. So let's see. So it's pretty easy question. Although you see Z2 minus Z1, Z2 minus Z1 mod, it is given over here. That is saying that it's less than E, and there are different statements that we have to find. It's okay. It's pretty easy. So Z2 minus Z1, if you see, then that is the distance here, and this distance is always less than, you can say, that the arc produced over here. So arc produced by this angle, arc produced by this θ2 angle will be less. So we can say very safely that is Z2 minus Z1, what we have written over here. Z2 minus Z1 is always less than, and it means Z2 minus Z1 is always less than θ2 angle. So length of direct distance is less than length of arc, you can say. Length of distance is less than length of arc, you can say. Length of arc. This is a formula, you can say. Means it's very obvious here. No need of saying that's very formula. θ2. Similarly, if we go for Z3 minus Z1, sorry, Z3 minus Z2, Z3 minus Z2, what is Z3 minus Z2? Another point that we say, that is Z3 minus Z2. Let's say Z3 minus Z2 mod. Then it is less than θ3, correct? So similarly, if we go and vertically we write this all. So what we find here in the last, Z1 minus Z10 mod is less than θ1. So if you add this simply, we can say that it is simply what we see over here, that is the sum is less than θ1 plus θ2. Now add this vertically, add entire thing vertically. So what we will recall here, and we will add this all, and what we will say, what we can see, that is Z2 minus Z1 mod plus Z3 minus Z2, Z3 minus Z2 plus dot 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 plus Z1 minus Z10 mod is less than, θ1 plus θ2, actually we can write, and plus so on up to θ. That is so on dot 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 plus θ10, right? And here that is equal to, means this length is equal to, that is 2 pi as per code it is given. So this implies that here means this part, the statement is correct. So this statement is correct. This implies that P statement is correct. P is correct. Okay. Right. So if P is correct, then what we see here, also we can say that Z2 minus Z1. Now use the square difference formula for Q statement. As in the Q statement, Z2 square minus Z1 square, Z3 square minus Z1 square. If you see along this wall, then you will find this also making like this one. So we get some more space over here. So for Q statement, what we will recall over here is applying a square difference formula. So what we will say that Z2 square minus Z1 square, Z2 square minus Z1 square mod, that is mod, is equal to, that is Z2 minus Z1 into Z2 plus Z1. Right, and by using triangular inequality Z2 plus Z1 is, you can say over here, that is Z2 plus Z1, we can write Z2 plus Z1, we can write, which is less or equal to mod Z2 plus mod Z1 by using triangular inequality. So for this, we can say here, this is mod of Z1 plus Z2, and this is Z2 minus Z1. So Z2 and maximum value of Z2 and Z1 is, that is a unity, one unimodular complex number. So simply we can say 2, and that is 2 times of Z2 minus Z1. So by joining this, we say if we add this like this up to 10 terms, like this and this and this, and up to Z1 minus Z10 whole square. So in each and every we get this is which is less than already 2 pi. So that is 2 pi, and so this entire theta, these are the actual theta, nothing else. So if we join this P statement with this, and we find theta will be less or equal to 2 times of, that is 2, and this is 2 pi. Means that is 2 times of 2 pi. So finally that is equal to 4 pi. So this statement is also correct. So finally we can say both the statements are correct, and which options will be correct. So that what we will find that both P and Q are true. C option is correct. So in this way we completed section. In the next video we will discuss about section 3, where is section 2. In section 2 there are 3 questions which are more than one correct numerical ability. This is JEE paper 2021 and section 2 part. In this section there are 3 questions. Again we can see that here there is a numerical value, and there is, although no negative marking here, and plus 2 marks will be awarded. So let's start for the 3 questions, although these 3 questions are based on comprehension pattern. And here in this is first time in IIT that in comprehension pattern, despite of single choice, they have given numerical ability type of questions, numerical values type of question, you can say. That let's start. So question number 5 and 6, the one of the comprehension, it is based on probability. So 3 numbers are chosen at random, one after another, with replacement. Mind this point, here there is a with replacement. From the set of 1 to 100, let P1 be the probability that the maximum number of chosen number is at least 81. So whenever there is at least, that is, the number is at least, we say. Mind this point, what is at least? So if you say this is as at least, so for at least, whenever there is a at least word is there, so we have to go for 1 minus, means complementary event concept. So 1 minus probability of at most you can go at. At most means as at least 81, 81 is to be considered. So at most 80 you have to consider for that. And let P2 be the event, that is means that the number of that means minimum number of chosen is at most 40. Okay. So what we will go ahead. So let's go for probability P1 first. Let's see. Okay. So let's see. So let P1 be the probability as it is given the question. P1 is the probability of probability. Let me write probability that maximum number of chosen, that maximum of chosen number is maximum of chosen number is, you say 81, right? That is what we recall, that is 81. Okay, fine. So the maximum number of chosen is here, let's say 81. Let me write, that is 81. Okay, that is 81. Now, so this probability can be evaluated as the word is at least. So due to this at least, what we get, 1 minus probability of means probability that minimum no, not minimum, because we have to go for at most now. So maximum, you say that it is maximum of chosen number is here 81 to be considered. So we have to, as we are subtracting, so we have to go for 80. So maximum chosen number is 80. That is the important point to be noted here, nothing else. And so maximum chosen number is 80, correct? Okay, fine. So once we get this idea, that is maximum chosen number is 80 over here. So how will we tackle? So that is required probability is 1 minus 80 and total number of sample space is 100, and all the numbers, all three numbers will be 80 by 100 into 80 by 100. Now solving it's pretty easy. You can say 0 0 related, and here we got 1 minus directly 8 and 64, 1 of the 8, 25, that is 125. So that is 64 upon 125, correct? After subtracting, what we call P1 will be, that is, that is 61 125, okay, 61 divided by 125. So finally, what they are asking here 625 divided by 4 upon P1. So 625 divided by 4 P1. So for this, you have to say 625 P1 divided by 4. And we can go ahead like this way. It is nearly, that is, when you put the value here, 61 upon 25, 125 calculating, we will get 76.25 nearly. It's okay. So this is the answer. Now for the value of 125 by 4 P2, as here they are asking 125 by 4 P2. So let's see for another one. So P2 is the probability that the minimum number of chosen, here minimum number of chosen is at most 40, is at most 40, right? So the same idea we will go for at least 41, right? So go ahead. So probability, that is P2, what we say here, probability, let's say P2 is, it is as per question, probability that minimum number of, that minimum of chosen number is, minimum of chosen number is, that is, minimum of chosen number is at most 40. So as per question, there is the requirement over there. So here you can find by the complementary concept. So P2 is equal to 1 minus this probability. And we can write also that probability that here we write minimum only, minimum of chosen number, minimum of chosen number is at least, number is, you can say here, that is at least, minimum of chosen number is of chosen number is, we have tried at least, right? At least. So in this case, we have to go for 41. So at least 41. So what is the, that is 1 minus 600 by 100 to the whole power 3. And that is 1 minus, that is 2, 3, 6, 2, 5, 10. So 3 cube, that is 27. And that is, what we say here, 125 once again. So solving this, 125 minus 27, that is 98, and that is 125, okay, and that's our final answer. So therefore, what we say, 125 by 4 P2 is equal to 125 by 4 into, what we say, 98 on 125, plug in this value P2 over here, solving that, what we call 24.50. So that's our final answer. So here, one of the answers is 24.5, and again matrix A is 0. So for consistency, determinant of coefficient matrix A is 0. Let me write here. First we solve A part, first part, question number 7. So since determinant of coefficient, determinant of coefficient matrix A is 0. So for consistency, for consistency for consistency, what we write? Adjoint of A into B is 0, right? So this implies first we write A. What is the A matrix? The matrix A can be written as like this. The matrix A we write like this. That is, if you see how this becomes 0, as this is 1, 2, 3, 4, 5, 6, 7, 8, 9. It's very clear. So that's why what I'm saying here, this is coefficient of A. That is, coefficient matrix A is 0. So determinant of quotient matrix, as that is 1, 2, 3. Let me show you. 4, 5, 6, 7, 8, and 9. If you solve this, then you will get this as 0, right? And here, that is B is equal to, what is B? B over here. So B will be, that is, let's say this B, okay, this, and let's say this is B. Achha, for matrix we write here in the matrix form, this is also determined. So now when we are writing matrix, then the matrix is not going to be 0. It's okay, this is the matrix value. Its coefficient of matrix will become 0. Coefficient means determinant of A will become 0. And B we are writing as the matrix if then this will be alpha, beta, and here gamma minus 1. And here you can say that determinant of A, right? Determinant of A will become 0. We can see over here, that is, determinant of A is also 0. As from here you can evaluate. Now that is, we have to find adjoint of A into B, B. So adjoint of A into B we have to multiply. First find adjoint of A. How to find adjoint of A? We can write adjoint of A. That is, we have to use this matrix as a cofactor. So right like this. Here this is adjoint of A. So for this one, what the value of 1 will be? That is 5, 9, 45 minus 48. That is 3 minus 3. So this will be minus 3. Similarly, you can find other values also. 6 minus 3. And here that is 4, 2, 9, 80 minus 24. That is 6. And position is negative, so minus 6 plus 6 minus 12 here. And that is 6. Similarly, minus 3 and 6. And you have to work it out properly. That you will get minus 3. And that is B. For B, that is this one. So we have to find adjoint of A into B. So we can write like this one. Adjoint of A, let write B here also. So multiplying with this B, adjoint of A into B matrix, that is called B. We have to recall here B matrices alpha, beta, gamma minus 1, right? So we can write here, that is alpha, beta, gamma minus 1. So we take this value over here, and let me erase this equality. So now we are multiplying with this. Once you multiply like this way, so the value will be here, that is equal to that what we call, and adjoint of A into B is equal to 0. So this provides this value will be as multiplying this one, result is alpha minus 2 beta, alpha minus 2 beta plus that is, take out 3 common over here, no? So 1 and 2 and yes, so alpha minus 2 beta plus gamma minus 1, correct? Gamma minus 1 is equal to 0. It is alright, as 3 into 3 order matrix, 3 into 1 order matrix, so it will be 3 into 1 order matrix. So 3 into 1 order matrix, the result will be 1 only. And here you say that mod of M will be, and what is mod of M? If you solve this mod of M, means matrix that is given over here. Determinant of m alpha, that is when you solve this one, you will find alpha minus 2 beta plus gamma minus 1. So that is what we same over here, that is alpha minus 2 beta plus gamma minus 1. So alpha minus 2 beta plus gamma minus 1. Actually it is gamma only. So that on transposing we will get this as 1. And this is the value of mod n alpha. So the value will be 1. So answer is for 7th part is only 1. Okay, fine. So we recall here. Answer is mod of m is 1. Okay, well, what about this one? D. The value of D here, we have to find the value of D. Let's see how to find value of D. Let me check this one. So shrink this, make some space here at least. Okay. This is for 7th part, question number 7th part. Okay. Now we'll go for question number 8. Let's see for question number 8. Okay. So question number 8 is here. If you see, this is the value of D. How to find the value of D? The value of D is, as you know, this plane, let P be the plane, all those alpha, beta, gamma above the system of linear equation, D be the square of the distance of the point 0, 1, 0 from the point that is from the plane P. So what we see over here, that is we have to do that plane equation. We have to write this equation of plane and making the sphere of the distance, that is nothing else here. So plane P will be simply plane, that what we call P. Plane P is x minus 2y plus z. This one, x minus 2y plus z minus 1 equal to 0, and a square of the distance, and a square of the distance from 0, 10. From 0, 10, when we have to find the distance of the plane, then and a square of the distance from the plane where we have to, okay, right, like this, 0, 1, 0, that is D distance formula, you know, D is equal to ax1 plus by1 plus c upon under root x squared plus b square, that we have to apply over here. So this is 0 plus ax1 plus by1, only 2 will be left over here. So 2 and 1, that is 3. Okay, and z is also 0, you know. C part is 1, so minus 2 and minus 1 mod, we will put here 3 upon root 6 under root 1 square plus 2 square plus c, that is 1 square. So 1, 1, 2 and 4, 1, 6. So root 6, and that is whole square. This is section 3 of IIT JEE 2021 advanced paper. In this section there are 6 questions. So one or more than one of these 4 options is correct over here. Negative 2 marks is there in other cases. So let's start. Question number 11. Question number 11 belongs to matrices, more than one correct option. So we have to go through options. As E matrix is given, P is here, F is also given. So you see this is F equal to PEP. So for PEP, let me make it P square and then multiply with this E, and then we will go for this one. Okay, let's see. So for first option, if we see, that is PEP, that what we call, that is P, E and P. So PEP can be written like this, as you know. Here this one is P1001, and that is P. Then after we will write this one once again, and E, that is 1, 2, 3, 2, 3, 4, 8, 4, 8, 13, 18. Okay. So let me write first P. So what is P? There is what we call here. Let me write 1, 0, 0. Okay, 0, 0, 1. Okay. and 0, 1, 0, right? So, and what about the E? E is given as 1, 2, 3. We had seen 2, 3, 4, okay, 8, 13, and 18. Fine. So, what about this one P? Once again, we have to copy this part. So, this P is same. Let's see. So, this will be P. Now, what do you say here? That is equal to, we can write, that is, if we multiply this to this each and every elements, then what we will get here after multiplication, first row to first column, 1, 2, 8, and 9, that is 1, right? So finally, that is 1 into 1, and all the others are 0. So this is 1, similarly 2 and 3, correct? So here, that what we call 0, 0, 1, that is 8, okay, 13, and then 18. You check it and go ahead and do it properly. That is 2 and 3 and 4. We are done this. So another matrix, that is 1, 0, 0 and 0, 0, 1, right? And there is nothing, that is PEP we have written here. So that is 0, 1, 0, 0, 1, 0. So as we have seen over here, what we got, let me see. So 1, 3, 2, right? After multiplication, this, what we write here, that is 1, 3, 2, and that is, so this element, this 2, 1, second row, first column, that is 8, okay, correct, and then after 18, and then after what we say here, 3, 2, third column, that is 13, 18, and here that is 13, right? Others are 0. So what we write? 13. Okay. What about this one here? 2, 4, and 3. Okay, fine. So as you will see, that is P square. What is P square? That is 1, 0, 0. That what we recall here. So for P square, we have to make this P. As P, we know this one as P, and once again this one is P. So here that is P square, and then after multiplying, what we will get here, we have to do this as P square. What we can see, that is identity matrix, that will become 1, 0, 0, 0, 1, 0, and 0, 0, 1. We can see over here. So that what we solve here, that is P square is equal to I. So what the options are there? P square is this one, and P square we got this one, okay, identity matrix as it is. And what about this one here? PEP, that is F. So F, you can see 1, 3, 2, 8, 18, 13, and that what we call 8, 18, 13, and 2, 4, 3. 2, 4, 3. This is F. This is nothing. This is called, you can say this is F here. Here what we see, say this is F. Okay, fine. So it's nothing, it is F over here. Okay. So this is what we call F. This one is F. As we can see over here, this one is F. Here you can check. You can check this word is, that is nothing, it is F over here. Right? This is F, you can see over here. So this option is also correct. Okay, first option correct. Now go about second option. If we see second option, that is EQ equal to, yeah. So finally, let me reduce this entire thing. This is for first option. Okay. Fine. Okay, so what about another second option? So if we see is for second option, then what we get, that is EQ plus PFQ inverse. So let's see. And that is EQ, EQ plus PFQ inverse mod. This one is given, and here this is equal to, what do you say, that is EQ, it is given as per in the option EQ plus, we have to verify this PFQ inverse. Okay, where Q is, there is no information about Q over here, as Q is only non-singular matrix of order 3 into 3, and which of the following is administered. So nothing information is given by Q, just only mod Q shouldn't be equal to 0 as it is non-singular. So what do you say here? As if we see mod E, what about mod of E? Means determinant of E. So determinant of E we get 0. Determinant of F also we get 0. By applying determinant property, you can see that it is very obvious. And determinant of Q, as per it is given non-singular, so it is not equal to 0. Now, so what we call EQ mod is equal to, one can recall as mod E into mod Q separately, right? And that is equal to, as both of them are mod E is 0, so mod EQ we can write as this is 0. So this option is 0. It's okay. It's nothing to see over here. This part is undoubtedly, this part is 0, right? So this part is undoubtedly 0. So EQ becomes 0 once you see over here that EQ is going to be 0. Mod of EQ is 0, right? So once this is 0, then this implies that PFQ inverse. What about this one? Let's see PFQ inverse. About this one, as this is the matrix. Huh? So PFQ inverse, here we have to find the determinant, not matrix. PFQ inverse. I have written here matrix. So you have to think about this one as determinant. So this is also determinant, and here also you have to say about determinant. So think about this determinant, right? So we have to evaluate from here, that is called PQ inverse, right? So what do we see here? That is PFQ inverse. So PFQ inverse is equal to, some can say that is PF mod P, right? Mod F, and what about this one? So as Q inverse, so we write mod Q. As mod Q is not equal to 0, and mod P and mod F, if you see mod F, that is 0. So the result is 0, right? So PF, so left side and right side, both the parts are 0. So what about this one in the left side? So what we call, if we say, let's say T equal to EQ plus PFQ inverse, right? This is the determinants, let's say. So if we go for T and we multiply Q in both sides, then what we will recall here? So post multiplication of Q, that is TQ is equal to, what do you say, EQ square plus PF, because Q of Q inverse, that is identity matrix, and that is I. So 3 order identity matrix we can consider over here as EQ square plus P square. We can write P square E P, because this one is for I, that is PF, right? So PF we can write here for this F. From here you can see, that is from F what we write, this part, okay, as F. For F we can write PEP. For F what we can write here, PEP. For this F. For this F, we have to write here, that is the PEP. So from first option. If you see from first option, I am writing over here, that is PF equal to, that it means from the first option. One can write over here that what we see here. Okay. So let me manage the space. It's clear. So what we see over here, when we substitute the value over from here, this one is that what we call F. For F we can write PEP. So you can see F we are writing over here PEP. Okay. So for F what we are saying here, that is PEP. Okay. So for F we write PEP, so that we got this one P square EP. So once we get P square EP, then you can say over here that is EQ, okay, EQ plus EP. Why? Because as you know, that is P square is equal to this one as identity matrix. Now you can apply this concept over here. P square, that is the identity matrix. Okay. So what do you say about here? Okay. So EQ plus EP. No, sorry, this is EQ square. Forgot this EQ square. Not, you can take out E common. So once you get E common, so that will become Q square plus P. Okay. So that is Q square plus P. And this implies that that is called TQ determinant of TQ, that what we call here, that is E, determinant of E under bracket Q square plus P. Okay. And this shows that here mod T into mod Q is equal to mod E is determinant and Q square plus P. That is the determinant. And this implies that here determinant of T will also be 0, because Q is not equal to non-singular, as Q is not 0. So T we have assumed any matrix. So this T, and what the T is EQ plus PFQ. So this is not going to 0. So what we conclude that this B option is, right side is 0, very obvious, and left side is not going to be 0 as we have considered this T. So B option is incorrect. We can say that B option, A option is correct, B option is incorrect. Now test about C and D. Now from C and D, very clear. If we see C and D option, so before to just check C option, let me shrink this thing, entire value over here. So let's see this much. Okay. What about this one, Q inverse? This is perhaps PQ of inverse. Okay. So PFQ inverse, we have to clear. That is Q inverse. Q inverse. PFQ inverse. Okay. Fine. So that is PFQ inverse. It is given us here. So PFQ inverse. We have evaluated, we don't count. Anyway, so another option, that is what we have to show here. EFQ upon is greater than EF square. Let's see over here. So this is whether correct. This is perhaps correct. Mod T is also going to 0. So B option is also correct. Yes. As B is option is, both of them are 0. No? So this is correct option. This is correct option. Yes. This is the correct option. Now check for C option. Now check about C option. Okay. As for C option, if we see that for C option, you can see over here, that is EF whole cube, as they are saying, EF whole cube determinant is greater than EF whole square. EF determinant whole square. Let's see. As from EF, it is very clear. That is, this result is 0. Clear? So this result we can recall over here, that this result becomes 0. Okay. So this result is going to be 0. Clear? But as you know that this result is also going to be 0. Correct? So what we see over here, that is, this result is also going to be 0. As you can see here, this result is also going to be 0. So both of them are 0. So is it possible that 0 is greater than 0? So 0 is greater than 0. So what we conclude that this is false, no, or true. This is not possible. So that is called false. So this statement is wrong. So the answer will be not correct because we have to choose correct options. Although both of them are equality is not there. So that's why we can't consider this. Now what about this one D? Let's say D choice. If the D choice is the sum of diagonal entries of P inverse P EP, let's see. In this much line, well, let's see over here. For the last option, okay, let's see for the last option. As you know, that is P square is equal to I. Here you can see P square is equal to, this is I, this is identity matrix, you can say. So this implies that is P inverse, this will imply here that is P inverse is equal to, what do you say here? That is P, clear? So what we recall, that is P inverse of FP, as we have to find here P inverse of EP. Na? So P inverse of FP if we see, that is P inverse of actually EP we have to go and we have to find PE plus P inverse of FP. So let's see over here. So that is P inverse of FP, that we can say that is PFP. Can't we write like this? PFP. So what we see over here, that is P inverse of FP is equal to, for PFP, for F what we write for FP, that is PP, P, P, E, P and P. Correct? So for F we can say that is PEP. From here you can say PEP, that we have chosen here, that was F. It was the first option. If you see, that was correct also, we have shown here. PEP is F. So F is over here. We have already shown this. So instead of PEP, we can write here, that is F. And finally, what we recall here. So PPE P square. So P square, that is I, and this one is also I. So the result will be E. Finally, we got here P inverse of FP is equal to, that is E. Okay. So what we say here, as we have to evaluate P inverse of FP, P inverse of FP plus E, we have to add. So add this one. So what we conclude that, we concluded that E plus, what about this one? This is P inverse of FP. So E plus P inverse of FP can be written as E plus, and what the value of this one? Entire we have shown that this is also E. So finally what we can recall, that is 2E. Correct. So as 2E, so finally what we conclude, that is P inverse of EP plus F P inverse of EP plus F is equal to PEP, that is PEP and plus F, and that is equal to 2 PEP. Okay, so we can say for F we can say PEP, and PEP is already present here, 2 PEP. So finally what we think about this one, that this is also 2 PEP, right? So for if 2 PEP, then what we can recall here, that is trace of 2 PEP means sum of diagonal elements, that is called trace. So that is trace of 2 PEP, right, is equal to 2 times of trace of PEP is equal to 2 times of trace of EPP. Also we can write, and hence we can say 2 times of trace of, for EPP, that what we say, that is 2E. So 2 times of E, trace of E, that is E, because P square becomes I, so that is E. Is it clear? That's what happens. So in this way, what we can see, this option is also correct. Yes. So this option is also correct. Only C is not correct. A, B, D options are correct. So in this way, you can handle the question. You can see in the solution at a glance. Now let's go through another question. This question belongs to application of derivative concept that is called monotonicity. Okay, this question is from application of derivative, and this is the function. One of the function is given quadratic upon quadratic. Numerator also quadratic and denominator also quadratic. So to analyze this, as in the first two options, increasing, decreasing, and onto and range, we have to discuss. So how to tackle this? Okay. So this is the question number 12. That is from application of derivative. That is quadratic upon quadratic. Let's see. So as in first two options, that is the monotonicity is asking, and here in the next two options, we have to think about range and onto function. As this is quadratic upon quadratic, so first we have to decide that we have to differentiate this, and by using quotient tool, we can differentiate it very easily. So let's differentiate. Dy by dx equal to is dy by dx. First of all, are planning to find dy by dx. So how to find dy by dx? Let's see. We have to apply over here quotient rule. So that is dy by dx is equal to, in the denominator, that what we call this one. Let's say that is what does the denominator, that is a whole square, x square plus 2x plus 4 whole square, and first of all, we have to recall denominator as x square plus 2x plus 4 and differentiate the numerator, that is 2x minus 3. Okay, that was x square minus 3x. So minus, that is x square minus 3x, and minus 6 was also there. Constant differential was 0. And here what we see, that is, we have to recall this one also, as you know, that is x square, and that is 2x plus 6. 2x plus 2, no? 2x plus 2, yes. 2x plus 2. Now, if we recall this, then what we say, multiply it properly. 2x cube, that is 4x square. Then we say 8x minus 3x square, minus 3x square, yes, minus 6x minus 12. Now, properly multiply this. Okay, and then after negative, this one for another bracket, that is 2x cube. Once again, that is 2x cube. Okay, and then after what we see over here, that is, yes, 2x cube, and that is minus 6x square. Fine, minus 12x. Okay, later on we'll manage, don't worry. Minus 6x minus 12, minus 12. This is also in bracket. Okay, so think about this one. Okay, fine. This is numerator part. Okay, and then after go for denominator, that what we say, that is whole square, which is as it is, x square plus 2x plus this one, whole square is there. Okay, now we got dy by dx. If we solve this bit properly, then what we said, 2x cube cancel and dissolve like this way. We got this one 5x square, right? 4x square, 6 minus 3x square, 1x square, and that is plus 6, and finally 1, that is 3x square, no? So that is 5x square, perfect, and plus that after 20x. 20x is also there. Okay. So finally, and here this is in denominator whole square. You haven't to bother about denominator square plus 2x plus 4 whole square. Okay. So entire the sign of dy by dx depends on numerator. So if we see, we use wavy curve method over here. So the wavy curve method is, that is, critical points are -4, 5 for the 20, and that is a 0. So if we see, then this is part is positive, negative, positive using wavy curve method. So increasing in interval minus infinity to -4. Okay. Close union and union 0 to infinity, clear, and decreasing in the interval, that is -4 comma 0, that is also, we can say, that is close interval. Okay, this is decreasing part. Now check for range. Let's see, because in other options range is also there, so that would be call as a range also. Let me shrink this entire thing. Okay. Now we'll think for a range. So as this is a range of f is, this one is given and f is onto function. So first of all, we have to recall a range in different situation, what the range will be. So in here we will find case 1 and 2 for the range. So for range, yes, that what we call here, that is x square y. What do we say? X square y cross multiply. You can think here for the range what the quadratic by quadratic we have to do. Let's say this is y and cross multiply and transpose. So finally what we call here, that is x square y plus 2xy plus 2xy plus 4y, right, equal to, that is x square minus 3x minus 6 minus 3x minus 6. Okay, and this implies, that is x square under bracket y minus 1 plus x under bracket 2y plus 3, solve it properly, plus 4y plus 6 equal to 0. Untransposing, we get this one, right? So what do you say here? Here the two cases arises. So if we see, then that is the case 1. One of the cases, this one, that what we call here this, and another case, that is case 2. That's called case 2. This is case 1. We can see here, and that is the case 2. So case 1. We'll consider this one case 1. So this is case 1. Okay. This is case 1. Okay. In case 1, y we have to consider not equal to 1 and discriminant is greater or equal to 0. So what we see here, 2y plus 3 whole square, right? And then after, yeah. Okay, so 2y plus 3 whole square minus b square minus 4ac, we have to do 4 into y minus 1 into 4y plus this part c, 6, 4ac. So that is greater or equal to 0. Solving this, what we will recall, that is 4y square, okay, plus 9 plus 12, you have to do calculation by yourself. 4, that is 4y square plus 2y minus 6, and that's greater or equal to 0. Okay, so finally what we conclude, that after this solving, what we see, that is 2y square, so 4y square, and that's minus 16, 16 minus 4, that is minus 12y square. So what we see here, minus 12y square plus 4y plus 33 is greater or equal to 0. and this implies this 12y square. One can write minus 4y multiplying with negative sign. Inequality will be changed here. That is minus 33. Right, properly. Minus 33 is less or equal to 0. Right. So this implies that is now factorize it. That is 6y minus 11, and this is 33 now, and that is so 12 into 33, 6, 11, 16, 6, and minus 4. So 6y minus 11, and that is 2y plus 3. Is this correct? 3, 11, 33, 2, 6, 12. Okay, fine. Less or equal to 0. Now using Wavy curve method, you can find this is the value is y equal to minus 3 by 2 to 11 by 6. We have to means eliminate the term that what we call 11 by 6. The term which is coming as 1. So 1 under curly bracket you have to eliminate, because y shouldn't be equal to 1. And in the case 2, now let's see over here for case 2. Let's shrink this. This is case 1. This is for case 1, you can say over here. Okay. Okay, fine. So that is the case 1. And what about case 2? If you see, there is case 2. That what we call here, let's say, in case 2, what we will take, that is if we consider y equal to 1. So in this situation, x square plus 2x plus 14 equal to, that is x square, numerator and denominator both of them are equal, cross multiply, that is what we recall, that is x square minus 3x minus 6, and this implies x square cancel out and 5x equal to minus 10, and that is we say here x equal to minus 2. So from case 1 and 2, what we will think about as x equal to minus 2. So for y equal to 1, that is x equal to minus 2 is also there. So from case 1 and 2, if we make the union of this both the situation, if we make the union of both situation here and here, let me make the union of these situation. This is the union sign, and so y belongs to finally what we will recall minus 3 by 2 to 11 by 6. What we were eliminating, that also we will entertain this one, and because at 1 the answer is real solution. So x equal to minus 2 will be also considered. So, but here in the option minus 3 by 2 to 2 option is given. So it's not correct. So finally, what the correct options are? A option is correct. B option is correct. Yeah, because it is in the interval 1, 2 in the interval minus 4, 0. So of course this is decreasing. No? So it is decreasing, increasing in the interval 1, 2. Increasing in the interval 1, 2. Yes, it's correct. Decreasing in the interval minus 2 to minus 1. Yes, this is also correct. What about C? So C will not be correct. No? So C will not be correct, and D will also not be correct, and A and B are only correct options. Okay, so this is the final answer. One more question is there from probability, another question. Let's see. Question number 13 is from probability. Okay. So let's say some conditions are given over here. Okay, this is the question number 13. Here in this question, this question is from probability, and that is a conditional probability somehow. And here the condition by this question, this is a very usual concepts which is very frequently asked in IIT JEE, and before this also the same type of conceptions that been already asked. So better just such type of questions we should go through set theoric approach. So we will use Venn diagram to solve this question. As E, F, G, there are the three events. So one of the events, so first of all, let me draw the Venn diagram. So for Venn diagram, let me draw this one. Yes. diagram. This increase the size so that other we also draw ABC. So one of them is, let's say this be A, and this you can call as similarly another set that is called B, that is, let's say this be B, and another that we to recall as another set that is called C. So let me say this is C. So A, B, C are the three sets here. Actually, A, B, C is not there. It is given as E, F, G. So probability of E is equal to 1 by 8. It is given in the question, right? And 1 by 6 for F, and for G that is 1 by 4. E intersection F intersection G, that is 1 by 10. Okay, fine. So let me first of all, what we have to do, we first make this A, B, C or E, F, G like this way. So that maybe somehow intersection is also there of A intersection B intersection C, like this. And let me recall this one. So let red one is E. Let me write here. Red one being this is E over here. This be E. Okay. And you can see over here that is, this is F. Let's say this be F, and this what we call, that is we can say this as G, right? So if we see over here, that is E, so probability of A intersection F, that is given here. Probability of what the data is given. So these data we have to find E intersection F intersection G intersection. First of all, what the terms we know, that let's we note down first of all. So let me do this one. Let me get some this diagram so that we can manage this properly. Okay, so if you see, this part is E intersection of intersection G. So E intersection F intersection G, that we can say that is 1 by 10. Although all things 24, 40, 15, 12, these all are and you can take this, and here we can say this is 1 by 10. So this is given as probability. This part is given as it is according to as per question. It is given as 1 by 10. Okay, this is E intersection F. So let's say this be that it means. So if we say E intersection F, you can assume that E intersection F is as, you have to assume something. So assume like this. Assume E intersection F, that is, let's say this is X. Okay, and for probability, that is probability of E intersection F, and for probability that we say E intersection G, we can recall E intersection G, this purple one means, that is, let's say this is Z, and you can say probability of F intersection, yes, you can say this as Y over here, this as Y also, right? So let me show this and so let me write here probability of, that is F intersection G, F intersection G, that is, let's say Y. Okay, fine. So probability of E intersection, we can assume this one, this part, let's say this part we have assumed over here. Okay, fine. So this is the solution part. So this is, let's say 1 by 10 is this. So this will be X minus 1 by 10, you can write, because E intersection F we have curated over that X. So we assume that is X minus 1 by 10, and that is what we say here. Better just you can say this is achha. So what we say here, that is X, Y, Z. It is very clear that is X, Y, Z should be greater or equal to 1 by 10, right? Because here, if it is the intersection is 1 by 10, then this should be greater or equal to 1 by 10. It's very clear, right? So what we think about here, better just to just sake of calculation, sake of for sake ease of calculation. For 1 by 10 we can write like this. That will be somehow easier because LCM finally we get 120. So we write 12 multiplied and divide with 12. So we can say 12 by 120. Better just write instead of 1 by 10. So this part will be, that is firstly let me write here this properly. So x minus, that is once again 12 by 120, right? And what about this one here? This will be, that is f. So what the f part will be? So if you see over here, f part, that is means this is 1 by 6. So to make it 1 by 20, we have to multiply this one. So this will, f will be 1 by 6. So okay, so that is we have to recall this as e part first. Okay, so e part, better just we write e part as 27 by, that is 120 minus x minus z, right? This part e part, in which f and g is not participating. So here what we recall this one, that is 32 by, you can calculate here, manipulate this, 32 by 120 minus x minus y, right? And what about this one here? Similarly, y minus 12 by 120, you can say here, right? And here also you can say z minus 12 by 120, because this entire thing will be z. So, and what about this one? So this will be 42 by 120 minus y minus z. If you write like this way, then you will get the all calculation very easy. So let's see over here. This is the entire thing of Venn diagram. So let's we calculate this as per. So once we get this entire idea, so now we can able to do anything. So what they are asking, let's see. They are saying that x plus means E intersection F intersection G complementary, means G shouldn't be taken. So what we have to think about, that is, let's say x, y, z, each and every we have to recall. No? So let me first think about this one. That is probability of x plus, first we write like this way. Look at that is x plus z. What about x plus z? So x plus z, we say less than, that is 27 by, that what we say, 27 by 120, right? This implies that is x comma z is less than 15 by 120. Okay, so similarly x plus y, that is less than 32 by 120. Okay, how this comes 32 by 120? That it means x plus y. So this part, that is x plus y. So what we say here, 32 minus 120. Okay, fine. So that we say this part is, this implies that is x comma y is less than 20 upon 120, right? 20 upon 120 separately. And what we say here, y plus z, what about y plus z, is less or equal to 42 upon 120, and this implies that is y comma z is less than, that is 30 upon 120. Now look at point here. So now we say probability of, as first option, that we say E intersection, that is, if you see over here, that is probability of E intersection F intersection G, or B option, let's say. Let me go for B option, let me see. So that what we call here the A option, that is probability of E intersection F intersection G bar, G complementary first, no? E intersection F intersection G complementary. So first part, let's see, probability of, for first part, probability of E intersection F intersection and G complementary, we have to evaluate. And this will be as like what we say here, x minus E intersection F intersection G complementary, means E intersection F and G is complementary. So that it means that is what we see here, x minus 12 by 120. This part will be there in which G is not participating, E and F is participating. So that is x minus 12 upon 120. So x minus 12 upon 120, right? So this will be less or equal to what we say solving this, that is x minus 12 upon 120, and that is less or equal to, of course, 3 upon 120. So is equal to, that is 1 by 40. So you can check this option is also correct. Yes, less or equal to 140. This option is correct. Anyhow, come to this another option. For second option, let's say E intersection E intersection F intersection G. Okay. So for probability of E intersection F intersection G, what we say, that is y minus 12 by 120. No? Y minus 12 by 120. So E intersection, let me write probability of E intersection, right? E complementary, no? E complementary F intersection and G. So that will be, that is y minus 12 by 120, right? So this will be, that is less or equal to what we call 80 by 120. Okay, so when you make a weight diagram, then the problem will become easy. 1 by 15 you will get. So probability of what we say here, E union F union G, right? And that is what we say here, that is less or equal to probability of E, okay, probability of E plus probability of F plus probability of G, okay. So substituting these values, what we recall here, that is 13 by 24, and that's the final result. So what we say here, probability of E complementary intersection F complementary intersection G complementary. This one for this part. E complementary, we have to find E complementary, F complementary, G complementary. That is less or equal to, how we will write here, that is 1 minus, less or equal to 1 minus probability of, this is this is called De Morgan's law. So probability of E, which is very important for ITJ, this is a favorite of JEE. So F intersection G, and that is what we recall here. That what we say, this becomes, that is, it means greater or equal to, that is greater or equal to, you can say here probability of union F union G, that is 11 by 24, and that is greater or equal to 5 by 12. So that is, yes, less or equal to, that it means equal to this part. This part is, means that what we call here, this part is this part, that is greater or equal to, that is 11 by 24, 11 by 24, right? And hence what we say here, this is less or equal to 1 minus 11 by 24. So 24 minus 11, that is, what we say here. Okay. So okay. So this is by De Morgan's law. Probability of E complementary, F complementary, G complementary intersections is equal to 1 minus probability of unions of this E, F, G. So we can say that is greater or equal to 1 minus, and substituting this value, that is called 13 by 24 over here, and that is greater or equal to, that is 11 by 24. So you can see this D option is not correct yet, C option is correct, but 13 by 24, this option is correct. So we can say C option is correct. Yes, B option is also correct. Okay. So A, B, C option is correct over here, and D option is wrong. Okay. This question can be also done without using Venn diagram also, by simple conceptions. Substituting these all values, we can do also this by set theoretic approach simply. Okay. So as if you say that I will dictate this also, means when when we have to find, so I'm giving a shortcut idea here. So probability of E intersection F intersection G complementary, suppose. So if we have to go through like this way, so what we see, so this can be written as this. This will be written like this way. You can see over here. We can write this part as means this will be less or equal to, if we consider A option. So less or equal to what we write, probability of E minus probability of simply G we can write over here. So which is less. So probability of E, that is 1 by 8, and probability of G, that is what we say here, that is 1 by 4. So you can say probability of intersection F intersection G. No? So probability of E minus probability of E intersection F intersection G, you can say. So 1 by 8 minus 1 by 10, then that is called not G, that is intersection entire this one. So better just we write like this way, not G, that is 1 by 8 minus 1 by 10. So simply we say 1 by 8 minus 1 by 10. So what we will say, this will be less or equal to 140. If you consider this one, so we can write this as less or equal to, this part will be less or equal to, that we can write probability of F, yes, minus probability of entire this one intersections. So what is probability of F? That is 1 by 6. So we can write 1 by 6 minus 1 by 10. So 1 by 6 minus 1 by 10, that is 4 by 60. So we can say 4 by 60, and that is called 1 by 15. So this option is also correct. This option is also correct. Let me say check for C also. As for this is less or equal to, simply we write probability of E plus probability of F plus probability of simply G. So which is less or equal to, what we will get here, 1 by 8 plus 1 by 6 plus 1 by 4. And solving this, what we will get, 15 plus 20, right? And plus 30, you can take out the LCM over here, that is 120, that we were using in the previous method. So that was 65 by 120, and hence we say 13 by 24, and that's our answer. So C option is also correct. What about this one? This is, of course, this will be the, like you can write 1 minus 13 by 24, which is not 5 by 12, that is actually 11 by 24. So this option is incorrect. So in this way also you can do in very handy manner. So this is quick approach, you can say. But I will prefer to use this one Venn diagram. That's okay. Come to the question number 14. This is again from matrices part. So if you see here, 3 into 3, once again multiple choice question, 3 into 3 matrices given over here, and mod M denotes the determinant of M, and let I be the 3 into 3 identity matrix, that what we call, that is such that I minus EF is invertible. Okay, so G is equal to I minus EF inverse. Okay, fine. So better just to write this one, G equal to I minus, that is called EF inverse, which is given over here. You can see this G is equal to I minus EF. This is given. So this part is given over here. You can see from question we are doing. So we are writing for G, that is I minus EF. Okay. So this is G part, which is I minus EF. So for this we can say G inverse. What about this one, G inverse? G inverse is equal to, we can say I minus EF. Once again, inverse of inverse, that is, it replies. So G of G inverse. When we write G into G inverse, then what we will get here, that is G minus I, because I is there. So multiplying this one, so we get here G minus GEF, correct? GEF, okay, because you can take out G common and multiply in G both sides, or you can say make a pre-multiplication of G in both sides. In this step, you will get this G of G inverse. So this is G minus G minus GF, but I is equal to G minus GEF. G of G inverse is equal to I. So this implies, therefore, for I we write, I we can say G minus G E F. Okay, so and also we say that I is equal to, that is I is equal to G minus E F G. I is equal to I, that is given over here. Okay, I minus EF. So I equal to what? So I equal to what we have to say? G minus EFG. E, we write also I equal to G minus EFG we can write. Okay, so this implies that is GEF is equal to EFG which shows that which option is correct over here. Which option will be correct for this? It shows that let me check which option is correct. The C option is correct. C option is correct from here. You can see. We can see over here that is C option is correct. Okay, so let's check. Here that is C option. C option is correct. Okay. C option is correct. C option is correct. Fine. So C option is somehow correct. Fine. C option we can say. C option this one. This one is C option. EFG is equal to GF. EFG. GEF equal to EFG. We say. Okay. Anyhow, C option is correct. Now check for B option. For B option, let's say, let me check for capital B option. For B option, how will tackle this? Let's see here. That is, let's say I minus FE, right? You can see here for B option. B option, that is I minus FE and I plus FG. So what we will have to write here, that is I plus FGE. Okay. Now let's see over here. Let's see about this. How to tackle this. So the idea here that what we go ahead for this one, that we say I minus EF. This implies I minus FE. Okay. Plus FGE. Multiply this FGE and minus, that is called FE FGE. FFGE, right? So this one. So what we see here, I minus FE plus FGE, and that is minus FG minus FE. So here what we have to do, that is not FG, that is I minus FE plus FGE minus, that is called you can take out a common over here, better just. So F, that we say, let me fill this step. So let me do this step. Better just like do like this one. Okay. After this, what is to say? I minus FE, correct? And plus, just copy out FGE. And for this very, we say minus F. And for EFG as we have already noted here, that is we got G minus I from previous, and that is E. So if you open it, then you will find FE plus FGE, okay, minus FGE, correct, and minus minus plus, so plus F of E, because I is there. So now let's see what left over here. So we say this is perhaps B option. So in this B option, it is 1. So I will be left. So FE you can see over here, that is FE related with this FE. Okay, and what about this one FGE? This one related with this one FGE also, with this FGE. So only it will left with I. That's all. So B option is also correct. Okay, so go for D option. Let me check for D option. Let me see for D option. How will we go for D option? Let's see. So for D option, let's see over here. I did about D option. So that is, what is D option? Let's see. That is I minus FE and I minus FGE. That is 1. Okay. So first of all, find FE and mod of FE. That is 1. And then substitute this value over here. So better just we can say, as you know, that is I minus FE. Let me use this. Let me get some space. Okay. This part. See this all. And this part is D over here. So for D option, let's learn about D option. Okay, fine. So if we see for D option, that is, as you know, that is mod of FE, means determinant of FE. That is I minus what we call FE. Okay, that is determinant. Say over here. That is determinant. And here that is another determinant, that is FGE. Okay. So what we see now, that is FGE. I, first of all, it is given the question I minus FE, I minus FE, and to another that is called FGE. Okay, and this implies this is equal to, after multiplying, that what we got here, FGE minus FGE FE. Okay, fine. So what do you think about this one? We say FGE, copy out as this, and if instead of as you say GEF, this for GEF. So F for this GEF, we write G minus I as from previous. So what we think about this one, that is FGE minus FGE, and that is plus FE. So this will become, that is plus FE. Let's say this is plus FE, and now this is related with this. So finally, what it left with, that is FE, and that's all. So you can see that is this option is also correct. Not, yes. So which one? The D option. So in D option, this is okay. So this is I. So but we are getting FE. So D option is not correct. So B is correct, then D is not correct. B is correct, as B is correct. No? B is correct, D is not correct. That is the same thing. You can see here. Although this is minus. Right? So D is not correct. Finally, what we concluded, that B is correct, D is not correct. A, what about this one? A? Yes, A is also correct, B is correct, C is correct. Okay, fine. Now, check for next question. This is question number 15 of JEE 21 Advanced paper 1. This is a very interesting question. That is from inverse trigonometric function, and it is a very easier part if you see over here. And such type of questions are repeatedly IIT asking. So, student who is very seriously preparing will never forget to solve this type of questions. So they usually do this questions. Let's see how to tackle this. So as in this question, here Sn0 to infinity, cot inverse, this result is given here. You can convert this as in tan inverse just for sake of convenience here, because or you can go through cot inverse only. But if you convert it in tan inverse, then it will be pretty easy, because options are also in this tan inverse. And for tan inverse, just like a VN method, it will be retaliate very easily. So better just convert in tan inverse, so that the thing will become easy somehow. As you can see, so Sn of x, what you will write, sigma of k equal to 1 to n. For tan inverse, you have to make it reciprocal. So that is x will be in the numerator, and this, what is the numerator, that is in denominator. So that what we are going to write over here. Let's see. So if you see over here, the question will be like this way, and the question will become easy somehow. So let's see. Sn of x. Sn of x is equal to, that is sigma of k equal to 1 to n as per problem. And what cot inverse was that? We are converting in tan inverse, and that will become in what the denominator, that is we are using in numerator over here, right? That is in numerator. Okay, let's see. So x divided by x, that is divided by 1 plus kx, and that is in another bracket, that is called k plus 1x, k plus 1x, and that is the base. So finally, what we see over here, that is sigma of k equal to 1 to n, that is tan inverse k plus 1x. Some student can write this as k plus 1 times of x minus kx, for that x we can write, and divided by 1 plus kx into k plus 1x. Okay, this is in the bracket. So we can see over here, that is we write sigma of k equal to 1 to n, k equal to 1 to n, and we think over here, that is tan inverse, that is k plus 1x, right? So k plus 1x minus tan inverse, that is kx. Okay, and now substitute these values by using Vn method. So finally, what we will get here, let me expand this. So we will get tan inverse, let's say, that is 2x minus tan inverse x. Okay, and then after in another bracket, when we put similarly, then we get tan inverse 3x minus tan inverse, that is 2x. Okay, and similarly go on this in the same manner, that what we recall here. Let's see. Just let me reduce this some more size. So as we were using this one, reduce this one. Tan inverse, that is plus. Now this one is tan inverse 3x. We had already used here 3x. So tan inverse 4x minus tan inverse 3x, and so on. Okay, and it will go up to tan inverse n plus 1x, that is, let's say, tan inverse, let me introduce this, reduce this with this part also. So this is what we call, and plus so on dot dot dot, we will go up to this one. So that is what we see over here, that is tan inverse n plus 1x, tan inverse n plus 1x, and minus tan inverse nx, tan inverse nx, and that's how finally welcome for the another term. So to make the space, let me reduce this one part also. This is the last part, that is so on plus dot 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 and plus this. Okay, so if you check the VN method, then what the term will be left and what term will retain over here. So you can see over here, that is the terms retained only, that is first and last term. So what we say here, tan inverse means in the first term, the second part is minus tan inverse x, and in the last term, that is the first part. So finally, what we will get here, that is equal to, what we recall, that is equal to tan inverse. Okay, so that we say n plus 1 x, fine, and minus, that is tan inverse, that what we call x, and that is Sn of x. You can say over here, you can say this will be Sn of x. Okay, so you will think about here, Sn of x, and that's our final results. So let's see over here this part. So tan inverse Sn of x plus n plus 1x minus tan inverse x, and hence if we they are asking as first option S10 of x. S10 of x we have to solve. So simply just replace this n with 10. So that what we call here S10 of x. S10 of x we can say that is tan inverse, that it means x into 11, means that is called when we put 10 plus 1, that is 11x simply, and minus tan inverse, that is called x. So when you pack this tan inverse x minus y upon 1, so tan inverse x minus tan inverse y, that is tan inverse x minus y upon 1 plus xy. So 11 minus 1, that is 10x, and that is upon 1 plus 11x into, that is x. So that is the final answer, and that's the result. So finally, what we will see over here, that is called tan inverse. So finally, the result will be tan inverse, that is 10x divided by, means 1 plus 11x square, and that's our answer. Okay, so this if we interested, you can convert in quad inverse also, but this is the same result, right? So A option is correct, undoubtedly, but for B option we have to convert it in quad inverse. So okay, so convert it in quad inverse. So we can say pi by 2 minus, one can say this one also, means tan inverse 10x upon 1 plus 11x square, no? And here the option is pi by 2 minus tan inverse 1 plus. Achha, one thing is left over here. So better just you can say this as pi by 2 minus quad inverse. Actually, the question, the option they have given like this, they have twisted somehow. So we can write pi by 2 minus quad inverse. Now make the reciprocal over here. Okay. So pi by 2 minus quad inverse, what we will do, that is 10x, because tan inverse x plus quad inverse x pi by 2. So we are writing like this, pi by 2 1 plus 11x square, because they are giving the options like this. So here what we see, that is pi by 2 minus, now if we are going to convert this as x as positive, so we can write here, that is tan inverse 1 plus 11x square. Now denominator will convert in numerator, and numerator comes in denominator, and that is 10x. So perhaps this option is correct. So A option is given in this format. Yes, 1 plus 11x square, and then after 10x. So A option is correct. Now let's check for B, C, and D options. So what about B option? Let me see. First of all, shrink and make some space over here. Okay. This will be sufficient to say over here. Yes. Okay. Now, what about this one? B. For this one, B option. So for B option, what we say, think about like cot of Sn of x. No? So cot of Sn of x, that is called cot of, we have to convert in terms of tan. Then after we will go this. So better just for limit n tends to infinity, may I write here? Limit n tends to infinity for B option. What we say? Limit n tends to infinity Sn of x. This we can cover up here. So this part. Okay. So for this part we can do like this way. This part we can do like this. Okay. Okay. Fine. So for this part, cot of Sn of x, we can substitute as like limit n tends to limit. Let me change the color so that we can distinguish between question and solution. So limit n tends to infinity is limit n tends to infinity. N tends to infinity. Cot of, for Sn, that is we say tan of n plus 1 x minus x divided by, that is 1 plus n plus 1 x into x, right? And this part is, that is called tan inverse of this one. So this is tan inverse of this and cot of this. So if we convert this in cot of cot inverse, so that we can write that as x. So better just you can write like this way, limit n tends to infinity. So if we say cot of, and if we convert this in cot inverse, not cos, cot inverse. Right? Let me write properly, cot inverse. Cot inverse, yes. And this numerator will become in denominator. So that is x cancel, and in denominator that will be nx only left, and the numerator is going for 1 plus, that is called n plus 1x into x, right? And this is cot of cot inverse. So once we say cot of cot inverse x, that will become x. So simply we have to apply here limit n tends to infinity, limit n tends to infinity, and that is we can say 1 plus simply cot of cot inverse x we write. So whatever that is, the argument will come over here. So entire argument, that is 1 plus you say n plus 1 of x square. Okay. So upon, in denominator, that is nx. We left with here. So this implies that is x. Clear? So what we will think over here, that is Sn of x, that is tan inverse n plus 1 of x minus tan inverse of x, that will be pi by 4. Okay, fine. So Sn of x, what we say here, let me write here, Sn of x, what we will think over here, that is, let's say Sn of x, that is tan inverse, we have already derived n plus 1 x minus, that was tan inverse x. Okay. This one is B option is correct. Okay. So for C, that we say means as a real root in zeros, so 1 more. So we like this S3 of x. So Sn of x, we know this one. So what about S3 of x? So we can say that A and B option is correct. Now we are selecting for C. So S3 of x, S3 of x we write like this way. That is tan inverse. We have to write 4x n plus 1x, sorry, and minus tan inverse x, and tan inverse 4x minus x. If we solve this and equate with this pi by 4 as per this given the question, as per this given the question here. So what we say here, S3 is given as pi by 4 of x. So what we see, that is tan inverse, this implies tan inverse, that is 4x minus x, you can say directly we write 3x. So that is 3x upon 1 plus, that is 4x square, and that is called equal to pi by 4. And this implies that is 3x upon 1 plus 4x square. So this we can say tan pi by 4. So directly I am writing here 4x square minus 3x plus 1 equal to 0, and this shows that discriminant of this quadratic term is that is 9 minus 16 means negative, so less than 0. Okay, so as it is less than 0, so no real root is there. So what is the conclusion? That is no real root is there. No real root. So here they are saying has a real root, so this option will be wrong. So C option is wrong. Now check for D option. We can see over for D option. For D, that is tan of Sn of 1 by 2, Sn of x is less than 1 by 2. For n is greater than 2. So for D option, if we see for D option, we go for D option. Then how we'll think about this one? Let me solve this. Green color. So that is tan of, according to as per problem, tan of Sn of x, that is given over here, that is less or equal to 1 by 2, you can say. So tan of, that will say tan of tan inverse, right, for Sn of x, that's what I'm saying here, and x upon 1 plus n plus 1, that is x square, right, and that is your final answer, and that is less or equal to, which is, you know, that is nx, tan of tan inverse x, that is x, that is means nx upon 1 plus n plus 1, that is x square. And if we apply here limit, so limit n tends to infinity, that is nx upon 1 plus n plus 1 x square, and that is equal to, you know, that is 1 by x. Okay, so we can see that D option is not yet correct, because that's 1 by 2. So D option is also wrong. So only A and B options are correct over here. Let's see the solution. This is the entire thing. It's okay. Although they have done the exercise with the limits, which is very obvious in such type of questions, they usually do. So one more question is there. If you see, that is from complex number. Let's see this question also from complex number. This can also be do. Okay, this is another question. Question number 16. It's belongs from complex number. So let's see. Although here the question is given for any complex number w is equal to c plus id, where argument of w belongs to minus pi to plus pi, left half open interval, or you say right half closed interval, where iota, that is under root minus 1, let alpha beta be the real number such that the complex number z equal to x plus iota y, satisfying argument of z plus alpha upon z plus beta, that what we say pi by 4. And what about alpha beta? It is alpha beta real numbers. Okay, so this is will be as it is pi by 4. So as this is pi by 4, so the angle subtended at center, that will be double of this angle, means 90 degrees. So that you can say here this will be the major arc, right? So the locus traced by this means the locus of this in the complex number, it subtends major arc. The ordered pair x comma y lie on the circle. This is the equation of circle. Yes, it's okay. And center, so alpha beta relation we have to find. And now the thing is very easy here. This question can be attempted in two different manners, either in geometry way, or you say apply the concept of argument. So argument of z1 upon z2, that is argument of z1 minus argument of z2. You can apply tan inverse x minus tan inverse y formula. And in this way you can get the results. So let's we attempt this question first of all by using geometry. Okay, so as we see, the circle is here. Let's say this is circle. Let me write this. Circle. So the equation of circle, that is, let's say x square, it's given in the question, x square plus y square plus 5x minus 3y. Just I'm copying what the equation is given over there. So this attempts that center will be, if you compare with x square plus y square plus 2gx plus 2f5 plus c equal to 0. So g will be here 5 by 2. So this will be minus 5 by 2 minus g minus f center, and minus, so that is f is here 3 by 2. So this is minus or minus plus now. So this will becomes 3 by 2. 3 by 2. This is center. And what about radius of the circle? So radius we can say under root of g square plus f square minus c. So that is 25 by 4. Fine. And that is 3 by 2 whole square. That is 9 by 4. and minus c, that is minus 4. This is c. So solving, we get 3 by root 12, right? Okay. So now let me draw this circle first. So let's we draw first. This is x and y axis. Let's say this be x axis, and this what we call y axis. Okay. So as we have to show the center is at minus 5 by 2 comma 3 by 2, minus 5 by 2 comma 3 by 2. Okay, and this is alpha is here as real number, so alpha and beta will lie on the x-axis, this coordinate. So minus alpha minus beta, we can say. Let me draw one circle at least. So its center will be like this way somehow. We can see this is the circle, let's say, and the point is here. This is the center. So what we see over here, that is, if we join this line, let me draw the line here, which is called radius of the circle. So the radius of the circle will be, let's see, this point, and join with this alpha comma 0, and similarly here also we join like this way. So connect to this part as this is the center. Okay, fine. So we say this part, and here you can see that this is alpha comma 0. Okay, so this is, let's say, minus alpha comma 0, and let's say this is what we say minus beta comma 0, because in the question it is given z plus alpha and z plus beta. So we say one of them is alpha and another is beta. So that we can write, you can assume any of them. Let's say this be minus beta comma 0 or minus alpha comma 0, that doesn't matter. So let's say this is minus alpha comma 0 and this is minus beta comma 0. So let's say this point is A and this point what we call B. Okay, fine. So if we see that on joining this two line, this line, that is, let me draw this line to here at least, and this point be on the periphery of circle, let's say. So what we get over here, let me see this line as like this, and we can join this line now. Then what we see here, so this is, let me extend this line as like this way. So this is, let's say, z, which is z minus alpha. So this we can say this will be z minus of minus alpha, we can say this length is. So here we see, if we see about this line, if we see about this line like this, we extend over here, and we think about this line as yes, and let this line be this way, and here let me make this some dotted line somehow, and so what we recall this line as z minus of minus beta, z minus of minus beta, right? And this is the point. Let's say this is any point variable. And here the center is coordinate is minus 5 by 2 comma minus 5 by 2 comma 3 by 2. This point is the point of center, you can say. This is the center of the circle. It's okay. Let's say this is the center of the circle. So let me put over here. This is the center of the circle. Okay. Fine. So this is the center of the circle, you can say here, minus 5 by 2 and 3 by 2. Okay. And so this coordinate, if we put here perpendicular, drop here perpendicular from here to here as radius of the same circle. So this is behave as isosceles triangle, and here that is minus 5 by 2 comma 0, minus 5 by 2 comma 0. Okay, fine. So let's say this is minus 5 by 2 comma 0. Okay, fine. And, that's clear. Anyway, so this angle is, this angle is pi by 4. You can see over here. This angle, we can say this is angle from here, that is pi by 4 as per problem. As you know, that is, here it is given z minus alpha, again z plus alpha upon z plus beta. So that is angle pi by 4. This one is angle pi by 4. Okay, Fine. So argument of, if we write it over here, that is what we say here, argument of z minus of minus alpha and upon z minus of minus beta, what we say, that is equal to pi by 4. Okay, so let the point A and B is, so this implies that point A is here, that is called minus 1 comma 0, and that what we call B point, that is called minus 4 comma 0. Okay, so that is point A and B is minus this one we can say minus 1 comma 0 and minus 4 comma 0, so that alpha will become, so here we can say alpha will become that is 1 and beta will become, that is 4. Okay, how this comes, you can see it's very easy here, that is this point is minus 5 by 2 minus 3 by 2 point, so this will be here, this length will be minus 5 by 2 comma 0 from origin, so as this point is minus 5 by 2, so we should think about here, that is A and B, that is minus 1 comma 0. You can see yes here, so that alpha and beta will become as 1 and 4. So 1 and 4 is only possible values because the product of alpha and beta. So in this way we can say which options will be correct. So alpha into beta, that both of them are negative. So so alpha beta here means point will be negative. So alpha beta both of them will be positive. So the product of alpha beta will be 4. So this will be the better option of alpha and beta. So this is the correct option, alpha into beta equal to 4, B option, and so C option will not correct, and alpha is minus 1 is also not possible, beta will be 4, yes, this is also correct. So this is one way. If we draw the circle over here on the complex plane, Argand plane you can say, then we can easily handle this question. Achha, well, this question can be done in one more method. I can show you here, that let me do with the concept of inverse trigonometric function as the formula tan inverse x minus tan inverse y. So another method I can show you here. This one, that is, this will be also helpful somehow if you not handy about with geometry. So let z equal to x plus iota y. Okay, so once you get this z equal to x plus iota y, so we can say tan inverse, that is y upon x minus alpha, because argument of z plus alpha, and minus that we say tan inverse, that is y upon x plus beta, right? So tan inverse x minus tan inverse y, and this result is pi by 4. So applying this formula as, you can say tan inverse, that is y upon x, that is we can say this will be plus alpha, no? Minus of minus alpha, so x plus alpha and minus y upon x plus beta upon, right, and 1 plus y square upon x plus alpha. So let's see over here, x plus alpha into x plus beta, right? This is the result entire, and here this is equal to pi by 4. Okay, so we can see over here, that is if we make a tan of pi by 4, that is 1, that will be also here we can say that this result is 1. Let me just pause this video. Okay, so this question can be we can do this one in alternate method by using inverse trigonometric function concept. So tan inverse x minus tan inverse y, we will use this formula. So let's see how. So alternate method is, that is tan inverse, we can say y upon x plus alpha minus tan inverse, that is y upon x plus beta, is equal to pi by 4 as per given in the question. So applying the formula tan inverse x minus tan inverse y, we will get this one, y upon x plus alpha minus y upon x plus beta that is 1 plus y square upon, we can say, x plus alpha into x plus beta. Okay, fine. And that is pi by 4. So as tan pi by 4, you get this is 1. So simply we can say that is y into beta minus alpha. Finally, because x plus alpha, x plus beta, take it common, you will get beta plus alpha. So that is beta plus alpha, and that is x plus alpha, x plus beta will be the LCM, and that is retaliated from denominator of the numerator and denominator of the denominator. So this denominator will cancel out, and the result will be in the denominator. The numerator part will left with the x plus alpha into x plus beta. Okay, and that is plus y square. Fine, and that is undoubtedly tan pi by 4 is 1. Now, if you cross multiply this, we can get the value of alpha and beta over here by equating with this equation of circle. As equation of circle is given in the question, x square plus y square plus 5x minus 3y4 equal to 0. So compare with this. So let me reduce this to make some space over here. So we'll now compare this equation after doing this one. First, let cross multiply this. Okay. So after cross multiplying and solving this all, we will get, let's see, y into beta minus alpha. Okay. And then after is equal to x square plus alpha plus beta under bracket into x, and that is plus alpha beta, and this one plus y square. Okay, so this implies that is x square plus y square plus alpha plus beta under bracket into x minus beta minus alpha into y, and thereafter plus alpha beta equal to 0. So if you compare with that equation, then we get alpha plus beta is equal to, we can see what is the coefficient of x over here. The coefficient of x is 5. So we can say here alpha plus beta will be 5. So you can see here alpha plus beta will be 5. And what about this one? Beta minus alpha, as it is negative. So beta minus alpha will be 3. So we say alpha minus beta will be minus 3. So we can say alpha plus beta, yes. So that we say alpha plus beta will be 5. And here we can recall alpha minus beta will be then minus 3, because minus is also there. So if you take it as minus 8 one side, so that is minus 3. So solving this, we get that is alpha equal to 1 and beta equal to 4. So this implies that alpha into beta also there is an option, so 4. So this will be also somehow better approach, and geometrically this will be also a smart approach. So there are the two different methods by which we can solve this complex number problem, and this is pretty easy problem, you can see. Okay, so let's go ahead and another section. So this is section number 4. Let me start for section number 4. In section 4, there are 3 questions, and here there is no negative marks are there. 4 marks will be awarded for each correct question. Number of real roots. So let's see. There's 3x square, and here that is minus 4 times of, that is mod of x square minus 1. Okay, and then plus, that is x minus 1 equal to 0. As 3x square plus x minus 1, we write like this way, and on transposing this mod portion in one side, that is 4 times of x square minus 1 mod. Now we can consider here there is a true situation. In one situation x square is greater or equal to 1, you can say. Let's say x square is greater or equal to 1 in first case. So this implies this will be treated as positive. So we can write here 3x square plus x minus 1 is equal to 4 times of x square minus 1, right? So this will be considered as positive. So solving this, we can say 4x square, and transposing this we call x square, although negative, so we can transpose right side x square, and hence this is minus 4 and this is minus 1 plus x, so minus x will be there, x square minus x, and that is minus 3. So that is minus 3 equal to 0. So this equation provides two different solutions. We can see over here, that is one solution is here, and another solution that is this claim over here. Let's see. One solution will be provide as positive negative, we can say, that applying Sridharacharya formula, that is x equal to, that we say minus b plus minus under root b square minus 4ac upon 2a. So 1 plus under root, that is 13 upon 2, and here that is x equal to 1 minus root 30 upon 2. So there are the two different solutions we can see over here. One is this solution and other that we call this one solution. Okay. So another solution, this is the another solution we can say here. So there are two different solutions, two real solutions we find in this x square is greater or equal to 1 case. So the answer will be greater than 2 or yet still. Let's say one more case when x square we consider less than 1. So in the case when x square is less than 1, so this implies that is 3x square as it is plus x minus 1. What about here? In right side the result will be negative. So 4 minus, we can write 4x square. And on transposing we get here 3x square plus 4x square, that is 7x square. So we get here 7x square, transposing this, and plus that is x, and here minus 5 equal to 0. And this provides, that is here once again the two solutions. So as you can see over here, this is also discriminant is positive, so we can get once more we get two different solutions, that is x equal to, by applying formula, that is plus under root, that is also, you know, that is this formula is called Gogo formula, minus 1 plus under root 141 upon 14, and that is, and sometimes it is called Umar Khayyam formula, minus under root, that is 141 is upon, that is 14, and this is Chinese formula, that is Chinese name, that is called Gogo formula, right? Now Gogo was more senior to this one, Sridharacharya and Umar Khayyam. So these are the method. Achha, one more method we can do by graphical approach. Okay, and this is one alternate method. By graphical approach also we can do this problem. So if we draw this on x-axis, and this what we call, we say that is, let's say this is y-axis. So let me draw this curve of this one 4 times of mod of x square minus 1 and 3x square plus, that is x plus 1, that is of x square minus 1 mod, and let me draw this one drawing. So this one drawing we draw like this. Fine. So we draw like this 4 times of x square minus 1. Okay, and we will draw the graph like this, and we will draw the graph like this way. This is the part of 4x square minus 1. Okay, so we think this graph is like this way here. So let me draw this mod of x square minus 1. So this part is 1 comma 0 and minus 1 comma 0. So let's say this is minus 1 comma 0 and this is also 1 comma 0. So this part is, you say this is symmetric, you can say check here the graph like this way, and here the graph is also like this way. It's okay. So these are the graph here symmetric. So okay, let it. So this is the graph of 4x square minus 1. Now we have to draw the graph that is called 3x square plus x minus 1. So it's a minimum point we have to select, that is here it will pass us through. When we put this 3x square minus 1, let me write here, this the graph is here, that is called
3x square, that is 3x square plus x minus 1. So when we put x equal to 0, so it passes through 0 comma minus 1. 0 comma minus 1 or subject to the scaling is not to be considered over here because minus 1, this length is 1, so we have to put here a bit downward. But on the scaling, this is, as you see, this is 0 comma 4. I'm taking y-axis here. The scaling of y-axis is just like this way. That's why we have considered 0 comma minus 1 over here. So it's a minimum point is, that is minus 1 by 6, you can say, by using minus b by 2a minus delta upon 4a, that is minus 13 by 12. You can evaluate over here. And then we will go for this one, smart drawing like this, like this way. So the graph cuts like this way. It's okay. It's yet not a straight line. It's we can select over here. That is, it's not like this way also. So the graph will be like this way. Although it passes through 0 comma minus 1, and this point is here, that we can say this is the negative part. This is the minimum portion, and this part will be over here. So let's say this part, we increase this part from here, and it also intersects with this 2 different points over here. So it cuts at 2 different points. You can see over here that here at 2 distinct real points, so it will cut this wing also. So if we proceed this part, then it will cut also at 2 distinct points, although this is minus 1 comma 0. So let me increase this part, and this part is also, you see, symmetrically about this. Okay, so this part is here, we can see this part. It's okay. So here also the it cuts at 2 distinct points. You can see over here. You can see this part also intersecting at 2 distinct points, so that it can look over here. And if we increase this part, this also intersects at 2 distinct points. So how many total points are there? We can see 1, 2, 3, 4. So at 4 distinct points, this all intersects. This is the graph of 3x square plus x minus 1, you can see over here. Fine. So with the graph also, we can say that the 4 distinct real points are there. So finally, the answer will be here. We can say answer is 4. Okay. Question number 18 is from solution of triangle SOT, you can see. And it's very easy question. By using simple formulas, we can evaluate over here. So let's go ahead. It is very, very easy problem. One of the easiest problem of this paper, you can say. AB, BC, CA, all things are given. So if you say AB, right, then this is, let's say, small c. When you say BC, then it will be small a. And when you say CA, so this is a tradition to write B and C and A. Let me change the color. So okay, so C will be root over 23. Fine, it is given. So what about A? That is BC, that is 3, and that is called 4. Fine. So cot A, can't we evaluate cot A? We can say B square cos A. We are using this formula B square plus C square minus A square. Actually cos A upon sin A. So first of all, we will use cos A formula. So that is upon 2BC. And for sin A, we can say KA. Let's say KA. This is for sin A. And similarly, you can say cot B, cot C also. So if we write here for cot B, then what we will see, we can see over here, that is cot B also we can write in the same manner. So first of all, we will go for cos B and then for sin B. So for cos B, you know, that is C square plus A square minus B square upon 2AC. This is for cos B. And what about this one, sin B? Sin B, that is KB. Okay. Similarly, cot C, yes, quad c is equal to, so a square plus b square minus c square upon, that is 2ab, and that is for sin c, that is kc. Okay, this much. So when we put these data, quad a, quad b, quad c at in the formula quad a plus quad b plus quad c, then what we will get here? Let's see. So this formula we will get here, this result, entire thing you can see over here. This one. So quad a plus quad c plus quad b. Let's say quad a plus quad c. Simply let me write here. Quad a plus quad c plus quad b. Okay. So that is the formula we write here. That is b square plus c square. That is minus a square. Okay. What about quad c? That is a square, this one, plus b square, and then minus c square upon, that is what we say, c square plus a square minus b square, c square plus a square minus b square, right? Because all these terms of sine, this is cancelled. So substituting these values here, we get here. Although what the term will be retaliated, you can retaliate here. As you know, there is a c square is cancelled with c square, a square cancelled with a square. So that is 2b square upon, that is c square plus a square minus b square. Okay. So when we substitute this here, 2 times of b square, that is 4, b is 4, so the 4 square, that is 16. Similarly for others also, a square, that was 23, as root 23 was there, and for 3 square, that is 9. And here once again minus 16. Solving this all, we will get this 32 by 16, and 16 2s are 32, and 2 is your final answer. So final answer is 2. Let's go ahead. Answer is, we write here, that is 2. So what? Okay, another question, that is question number 19. That is from vector chapter. You can say it is also pretty easy, as dot products of 3 vectors are given. And these 3 vectors are in 3-dimensional space. They are unit vectors, you can say over here. So as we can use this concept of here, volume of the parallelepiped, u dot u, as you know, that is u dot u, that is 1. And you know, that is u dot w. U dot w. What is about u dot w is given over here? That is 1. And mod w, that is given here 2, right? Because it is w is root 2, adjacent sides are. So that is what we say here, v dot v, that is 1, and here v dot w, so we get 1. These are the vectors. These are the vectors. Dot products are given. Let me change it. Okay. As you know, that the volume of parallelepiped is UVW. So volume of parallelepiped, volume of, we say, parallelepiped, is given by U, V and W, that is scalar triads, and that is given here as it is root 2. So you know, that is root 2 whole square, we can write as in the form of determinant. In the form of determinant, we write like this, like this. We can say over here, that is u dot u, okay, u dot u vector, and then after, that is u dot v vector, and then after u dot w vector. Okay, so that is here v dot u vector, and here v dot v vector, and here that is v dot w vector, and now w dot u vector, then after w dot v vector, and then after w dot w vector. As you know, that is u dot v is equal to, as it is not equal to 0, it is given in the question. So let's say this is lambda. So that is u dot v, that is, let's say, lambda, which is not equal to 0. Let. So you know, that is 2, root 2 whole square, that is 2. So we can write over here, that is 1 lambda, and substituting these values over here. So that is u dot u. Let me check here. With the value of u dot u, that is 1, that is lambda, that is, let's say, 1, and here once again lambda 1 1, v dot w, that is 1, w dot u, that is still 1, and here that is w dot v, that is 1, and this one is 4, w dot w, as mod w is 2. Okay, so that is solving this determinant, we get here 2 equal to, that is 4 minus 1 minus lambda into, relate this, lambda 4 lambda minus 1, so 4 lambda minus 1, and plus 1 into lambda minus 1. Okay, so what we get here, 2 is equal to 3 minus 4 lambda square, so that is 4 lambda square plus lambda minus 1, and that is simply what we recall here. Let me solve this part and retaliate this. Let's shrink this somehow so that it can adjust in this page. So this provides here, you can see that after solving this, what we get here, that is 4 lambda square transposing 4 lambda square, that is minus 2 lambda. Okay, and this is 3 minus 1 2, and 2 related, that is equal to 0. Okay, so this provides here the two different solutions. So one of the solution is here, we can say the solution is here, that is lambda equal to 0. Is this possible? No, it's not possible. So this is not possible. And what about this one? So lambda equal to 1 by 2, which is the possible case. So in this situation, as we have to find here, that is 3u plus 5v mod. So how to tackle this? Now we have to evaluate actually 3u plus 5v vector mod. So as you can see over here, this is under root of, that is 9 plus as 3u square, so 9 plus 5u square, that is 25, and these are the vectors, unit vectors, so that is 1, so plus 2uv, so 2 into 3 into 5, 6 5 30, so 30 into, and that is u dot v, that we called here lambda, that is 1 by 2. Fine, so that we say under root, and now you can solve this. So 9 plus 25 plus 15. Okay, so finally what we get here, 49. Finally, that is the answer is 7, and that's our final answer. So this answer is, as it is a single digit type of question, so the answer is here, that is called 7, and that is the end of the paper. Okay, fine. So this is the entire paper. We can take it a glance here. Okay, fine. Thank you to all of you.